Hello, welcome again to my YouTube tutorial channel. My name is Alex Turen. I was a VFX artist on High on Knife 2, and today I would like to show you how to create this effect, which is how to have about 40 to 60 particles, GPU particles that spawn every time you destroy an object, and all of those particles respect the original position of the mesh you're destroying. So it's really cool, and it's not using chaos. It's not using any kind of real-time destruction. It's pre-fractured meshes in Houdini, but real-time simulation using just like basic GPU collisions. So it's very lightweight. I'm going to show you an example where I have hundreds of chairs. You can destroy all of them, and the cost is very minimal because it's just like a handful of GPU particles. I use that to do some chairs, but also a lot of different types of effects during the game. Mainly like this wall here in the Wyoming mission, when you defeat a mini boss, the wall behind you explodes. And I wanted all the GPU particles to fit the exact mesh of the wall behind it. So I didn't want the cheap effect of like an approximation of a bunch of chunks that resemble the wall. I wanted the actual pieces to explode. So, we did a bunch of tests and figured out that chaos was quite expensive. So I developed my own method that I would like to show you guys. So let's begin. So I found this very pretty chair on the marketplace, Unreal Marketplace. So the first step will be to export that from Unreal to Windows Explorer. So if I press Control B, it's going to show me the name of the chair, which is UKNJB. Don't really care. Let's right click on this, do Asset Action, Export, and I'm going to put that in my destructible chair demo. I usually do a VFX folder and a from Unreal folder, and later on I'm going to need a from Houdini. So I know like which direction the FBX was going. So this chair is coming from Unreal, so I'm gonna go from Unreal. The name of the chair is gonna be this. For now, it's fine. And one thing I like to tick on the export is export source mesh. So if you have a mesh that was quads initially, and was triangulated by Unreal, it's going to export the initial quads instead. So export source mesh is very useful for that. I always take it on. It saved me a bunch of headaches of like bad export and stuff. So export the vertex color. Not sure I'm not gonna need that. The level of detail, blah blah blah. Let's export it as is. All right, in Houdini, this is the chair I was working on before. I'm just going to recreate the whole setup for you guys to see. So let's import the chair, which is already selected. And if you don't have a geometry node, just create one. I'm just going to use this one for simplicity for me. Let's create an object merge, call it in chair 2, for example. Then select the chair you just imported. There we go. Into this object. Now, just before recording, I noticed a strange issue where the edges are kind of disconnected on this mesh. I'm going to show you what I mean. As you can see, it's supposed to be one piece, but like for some reason in the export, the edges are kind of broken like this. So to fix that, you just put a fuse node in the beginning, and now it's one piece as it should be. So now that this is fixed, the first step is to put an RBD fracture, which is a very useful node that fractures everything with material type. So you can do concrete, glass, wood, custom, whatever. For this example, I'll leave it as concrete since it does a pretty good job already, and wood is more slow to compute, so concrete. I can already disconnect constraint, I'm not gonna use that. Primary fracture, I'm gonna use 2 points. Secondary fracture, 2 points as well. And if I put an exploded view, below that, you can see the work that it's doing. So This is cool, but I'm gonna need more than 2, I believe. Let's put 5. Okay, that's not bad. This is the secondary fracture. If I put 5 and 5 on both, all right, cool. Maybe more than that. What I'm gonna do later on is measure the area of each piece and delete the smaller ones. So basically, I'm gonna keep, let's say the 40 or 50 biggest pieces and delete all the rest. Because when you're gonna shoot the chair, the very small pieces, you're not gonna notice. You're gonna only notice like the big chunks going out. And then if I want to add them back, like very small pieces, I can just put some random chunks of wood and it is gonna fill the gaps and look fine. All right, cool. The next step will be to measure the area of each pieces. So if you take a look here in my exploded view, in the geometry spreadsheet, in the primitive tab, excuse me, you have name, the attribute name, which is different for every piece. You have 0, 5, 1, 0, 1, 1, 1, 2, etc. So all the pieces have a name. So if I go here in measure node and I go per piece, and the name will be a piece attribute name, by default is gonna do a geometry blah 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 area. Okay, so if you go here in the geometry spreadsheet in the primitive, you can see an area attribute, which is like the surface of every piece. And now with a surface area, I can delete pieces that have a lower value than what I want. So if I create an attribute wrangle, and I'm gonna take it from here, I'm gonna leave it on screen for a few seconds. Basically, you type in float threshold. So an attribute, a threshold with a label area threshold, and if I click this button here, it's gonna do this this control here. So I'm gonna go into primitive and raise the number. As you can see, it's gonna delete the smaller pieces. So all the values below this will be deleted. So if the area parameter is lower than this value, is going to delete the primitive. So I can keep only the big pieces. I don't have a lot of very small pieces. They're pretty much fractured how I like them. How many, if I pack just to see how many I have. Name attribute. I have 22 pieces, so that's pretty acceptable. Only 22? I find that hard to believe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, okay, 22. It's believable. So the 22 little pieces in Unreal is very easy to add, and it's not going to be very heavy on the memory and on the calculations. So next is the material. So you're just gonna have to create an attribute create node, set it to primitive string, and here you can type shop_material path for the name of the material. And here in the string, you put the material like it is in Unreal. So for me, it's MIUKN something. Just gonna paste it here. Cool. If you had a cushion and some wood for the frame, like two materials, you could create groups and put like two separate shop paths and combine them later. You can do that. Next, you just do a normal and a triangulate. Those two, for me, are not necessary because the normals are already fine and it's already triangulated. But if you had a mesh that is quads, you're going to want to triangulate it. It's going to make it go through the export without any issues. So normal, triangulate, cool. Next, I like to do a clean. just to remove the unnecessary attribute and groups. So I'm going to remove all the groups and all the attribute except name, shop material path, normal, and UVs. So if you didn't know, you can put a star and then this symbol, whatever it is going to do except name, except material, except normal. So I'm going to take that and that. Cool. So if you look at the clean here, I only have position, name, material, UV, normals. Whereas before I had like inside groups of the fracture, concrete. I had a detail attribute, and you know, all of this is gonna get exported if you don't remove it, and it's gonna add some weight to the file. So just clean this. You can do a pack after, a pack by name. So like I did before, pack by name, and path attribute, I believe I let it. Okay, so this is gonna do 1 point per piece. That's what that's what a pack does, if you didn't know. Now that it's packed, if you take a look here at the geometry spreadsheet and you go into primitive, you're gonna see the name of all the pieces is kind of hard to read, and it's kind of like a path. But what we're gonna want to do is in Niagara, we're gonna import the FBX static mesh as separate pieces, and for that they have to be named properly. So it has to look like this: piece 0, piece 1, piece 2, like very simple. So what I'm gonna do is a attribute wrangle again, and I'm gonna copy paste my code. So I'm gonna take, for the ID, I'm taking the prim number, so just like this number here, and I'm gonna do a new name that is piece underscore and the prim number, and setting it up as the path. So if I copy paste this on the primitive, you can see now I have P0, 1, 2, 3, all the way through 22. I'm just gonna rename this rename pieces, and you can do another attribute wrangle to put all the points to 0, 0, 0. So center everything. Center everything is just at p equals 0, so all the points are 0. So if you take a look at what it does, it just takes all the pieces and center them on 0. The concept for my whole setup is you have your pieces at 0, and then you have a point cloud that will tell all the pieces where they have to go. It's gonna make a lot of sense back in Unreal, but for now, like, just put everything to 0. Cool. So now that this is done, what you can do is a circle polygons, which I'm gonna rename to triangle immediately, because we don't want a circle, we want a triangle, and a circle with 3 sides is a triangle. So if you put 3 on the division and then the orientation to ZX, it's just a triangle pointing up. That's what we want. So you can do a copy to points, plug that in the first input, that in the second one, and now what you have, I don't know if you can see the chair, but you have a point cloud of all the pieces and where they should go. So I'm gonna export one FBX for the pieces, one FBX for the point cloud, and reassemble it in Unreal. So if you do FBX output, plug one here, plug one here. This one, I'm gonna place it FBX from, okay, yeah, give me a second here. Structable chair from Houdini. I'm gonna place it here and not in my previous folder. So this one is a static mesh. So if we follow the nomenclature, is SM static mesh FX. I like to do double underscore chair, name it however you want, point cloud. 0, 1. Cool. And for this one, we want to take build hierarchy from path attributes. So this is where the naming is important. It's going to build a hierarchy from the path attribute. So I'm coming back here. Houdini, static mesh, I think here, no. SM, FX, share, pieces, 0, 1. That's pretty cool. Save to disk. Save to disk, and now we can go into Unreal. Back in Unreal, I'm gonna start by importing my point cloud. You can use default values for everything except, very, very important, search for nanite and uncheck build nanite. Otherwise, everything explodes. Cool. I'm gonna create a new folder, call it pieces, and import my pieces into it. You can use defaults except for the material. In the material here, uncheck import material, and where it says search location, click on all assets. So when I click import, all my pieces from 0 to 22 are imported. And if I look at the material on it, it search through all the materials in Unreal and assign the one I assigned in Houdini. So that's pretty cool. I can now create an aggregate system. Let's choose minimal, create name it ns underscore fx double underscore breakable share 0, 1. Let's put it in the level here. Press Ctrl E for edit. Okay. First thing I'm gonna do is put it in GPU mode with fixed bounds. I'm gonna delete the sprite renderer and add a mesh renderer instead. I'm gonna click enable mesh flipbook and add my first piece, P0, to this. And where it says number of flipbook frames, do 23, because I have frames from 0 to 22, so that's 23 pieces. As you can see, all my pieces are imported properly. Where it says emitter update, I'm gonna add a burst of 23 particles. So right now it's all the same piece, but let's fix that with in particles spawn. You can add a static mesh location, and this is where you're gonna assign the point cloud here on both. So it's gonna complain about CPU access, just press fix now. And you can already see the shape of the chair taking form. So right now all the pieces are like P0, but you can fix that pretty easily. Here, when it's where it says mesh sampling type triangles, we have the sampling mode random. Let's put direct, and in the triangle ID, you can put return execution index. So what that's going to do is the particle index 0 is going to spawn the mesh number 0, 1, 1, 2, 2, etc. So the one last thing to do in static mesh location is here in the orientation sampling. We don't want any orientation. We want like 0. So instead of apply, put output. And here in initialize particle, where it says mesh renderer array visibility mode, we're gonna do direct set, choose the mesh renderer we created before, and put the execution order here as well. So we can see my chair in the correct position and orientation. I can see that I forgot to remove the exploded view from Houdini, so that's why my pieces are kind of spaced out. But it doesn't really matter. You just have to mute it in Houdini if you don't want that. So your emitter should be local space, so you can flip it like this. And now the work is pretty much done. All that's left to do is add point force, for example. Okay. you need the initial forces. So point force, strength, I don't know, 500. Is it enough? Simulation position. Can I add a offset to this? Oh. The node I was looking for is called solve forces and velocity. So yeah, my point force is really strong. Cool. Let's put the lifetime to random between maybe 0.5 and 1. The life cycle mode is system, that's fine. We're gonna make it loop on 2 seconds. That's pretty cool. Particle update scale mesh size. Let's multiply this by float and put a curve here. Oh, you need, yeah, if you want to use a scale mesh size, it's a weird behavior from Niagara, but you need to set it here. Scale, where it says mesh scale mode unset, you have to do uniform. And now it works. A little bit weird, but okay. Cool, so let's put that to curve like this. So now my pieces scale down. My point force is origin, convert, let's add vector, position to vector, let's put the emitter simulation position. So now I can have the point force be offset from the center of the emitter. What if I put 150? No, that's too much. 50. 50 looks good. I'm looking to add a force from the center of the chair, not the center of the emitter. So 50 offset in Z up looks good. We can save this. Add gravity. Okay. Collision. Distance field. Okay. Yeah, that looks good. I'm gonna add initial mesh zip force, rotation force, mesh rotation force. If I put it before, multiply by float, random. So if I have -1, -1, -1, -1. And this is random as well, so like 5 to 20. Now my pieces are kind of rotating in random axis with a random speed. Rotation mesh. Actually, all I have to do is put a drag. It's rotational drag. What if I put 10? Yeah, it's pretty strong, but it works. 2. Mesh rotation. Let's see if I put 2060. It's gonna rotate like crazy at first and stop quick. Rotational drag. Let's put 3. Yeah, that's pretty cool. The goal is to make it look like a real simulation without being one. Point force. Let's put a random from 50 to 200. Oh, 2000 is too strong. 500. So 250 to 500. It's kind of like a exploding chair. But yeah, that's how I did the chair exploding. So now, if I look here, I have 23 particles by exploding chair, so that's really not much. They are GPU particles, and you know, it's only like 23 little pieces. I could push this a lot further, but this is beginning to be outside of the scope of this video. So I hope this was useful, and we'll see you next time. Thank you.